Spoiler alert, there's a lot going on in this question, although you might have realized that just by looking at it and thinking, how on earth are we meant to find these integers? And the first thing to do is to get rid of that root on the left-hand side by squaring both sides. So I'm going to get this, and then I'm going to square the right-hand side as well. Which is going to give me, now 2 root 2 is actually root 8, so it's root 8 times root 8, it's just 8. Minus y times minus y gives me plus y squared. And then I'm going to get minus 2 root 2y and another minus 2 root 2y, so it's going to be minus 4 root 2y. Okay, and this is a little bit nicer. We got rid of the root. Yes, there's an extra term over here, but actually this is now going to be our route to solving this problem, because we're only interested in pairs of integers x and y. Now, x is definitely an integer, 8 is definitely an integer, and y squared is definitely an integer, because I'm only interested in integers x and y. However, for root 2y, it must necessarily not be an integer. It must be a surd, because we're only interested in y being an integer, which means that this must also be a surd. And therefore, I can equate the integers. It must be that x is equal to 8 plus y squared, and I can equate the surds. X plus root x plus 23 is equal to 4 root 2 y. Now there's two things. I've actually forgotten to mention something, and there's a point I need to make about the second one. Now, I have squared an equation, and when you square an equation, you can sometimes create solutions that don't actually exist. So let's look at the simple equation x equals 1. That is the solution. If I square it, then I actually introduce a plus or minus 1 solution, an extra solution. So I just need to be careful. That was like a simple, silly example as such, but it can apply to these more complicated cases. So I just need to check at the end, check for spurious solutions at the end. And there's one other point I need to make. I've assumed, yeah, okay, this thing here is a surd, except for the one instance when y is equal to 0. So I've got this is true, or y is equal to 0. If y is equal to 0, then I could, in theory, still get some solutions where, say, x was 2, and then this root would give me 5. But if this gives me an integer, and y is non-zero, then I wouldn't get any solutions. So I just need to look at the single case when y is equal to 0. And for this, I'm going to return to the original equation. Okay, but I do need to separate it into all these cases and do it carefully. So in this scenario, I'm going to get, well, it's still going to, okay, I can actually just substitute y equals 0 into here. So it's going to be x minus root x plus 23 equals 8. And I got to try and solve this to see if there's a possible solution where x is an integer. I can do this by rearranging it. So it's going to be root x plus 23 is equal to x minus 8. Now I've got it in that form, I can square both sides of this. When I square the right-hand side, I'm going to get x squared minus 16x plus 64, which is going to give me x squared minus 17x plus 41 is equal to 0. 41 is a prime number, but there's no way that I can put 1 and 41 in to get minus 17. Remember, they have to be, x has to be an integer, so there's no solution, no integer solution. And to be fair, if you didn't realize this point, you would have got away with it. But actually, away from the Senior Math Challenge, these are the sorts of things you do need to consider. Okay, so we're actually onto this one where y is not equal to 0. And we have this scenario. Right, well I've got my first equation. I'm gonna square this second equation. It's not gonna yeah, it's gonna give me something different this time, but it's gonna give me x plus 23 is equal to, I'm gonna square 4, 16, times it by 2, it's gonna be 32y squared. And what I can do is I can rearrange this one to make y squared the subject. Y squared is going to be x minus 8. And then I'm going to get x plus 23 is equal to 32x minus 8. So I've managed to eliminate y squared from the problem. It's still there as a solution, but we'll worry about that later. Let's try and find the value of x. And actually, because it's formed a linear equation, there's going to only be one possible value of x. X plus 23 is equal to 32x minus, right, I'm going to get 256. So 31x by minusing the x is going to be 279. And this actually gives x is equal to 9. Oh, all of that, and we've managed to get our one single value of x that can occur. Now, the question still remains, is that actually a solution? Because like I said, we had to check for spurious solutions. We've not even found y yet. So now I can return to y squared is equal to x minus 8. So y squared is going to equal 1, and y is going to equal plus or minus 1. So I have these two possible pairs, 9 and 1, or 9 and minus 1. Now, at this point, especially if you're running out of time, you probably think, one of these is probably going to be okay. I'm going to go for this one. And you would actually be right. But away from this challenge, we do need to check these that they work. Now, I'm going to look at the left-hand side. So check. The left-hand side is going to equal the square root of 9 minus root 32. And the right-hand side is going to be, well, I've got two different cases, but actually I can already see that one of them's not going to work because, the right-hand side is either 2 root 2 minus 1 or it's 2 root 2 plus 1. It can't be both. Like this can't equal both of these. So I can reject, I know that at most 1 is going to be a solution. Let's try and find out which one. And it's going to be hard to take a square root of this. So instead, I'm actually going to square 2 root 2 minus 1. Because this is positive. That's the key thing here. You tend to get spurious solutions when you square a negative and it becomes positive, but actually both of these are positives. So if I square this and I get 9 minus root 32, then that must mean that the square root of 9 minus root 32, which is, by the way, 9 minus root 32 is a positive number. If I square root that and I get a positive thing, that it must all be okay. So I'm going to get 8 when I do 2 root 2 times 2 root 2. I'm going to get plus 1, and then I'm going to get 2 root 2 times minus 1, and double that. I'm going to get 4 root 2, which is 9 minus 4 root 2. And if you bring that into the surd, actually it's 9 minus root 32. Hey, that must work. Okay, could be 100% convinced. I've done it pretty rigorously now, I've got to say. That must be my one and only solution. X equals 9, y equals 1. If you checked this one, you would very quickly see that you don't get 9 minus root 32. For a start, you're not going to have a minus in there, are you? There's no possible way because both of these are positive. So I'm not going to check that one, but you can if you like. Okay, I think this is a challenging question. I hope that you're happy with it.